Hi, this is Mike, and the purpose of this video will be to show you how to calculate the probabilities in 5-card stud poker. In other words, what is the probability of forming any given poker hand given 5 random cards out of 52? Before I answer the question on the number of combinations of each poker hand, let me ask you a simpler question, and if you know how to get the answer, you can skip ahead. So at El Pollo Loco, they have 8 so-called classic sides, which I listed on the left. They also have some deluxe sides, but I won't muddy the waters with that. If you order the 12-piece meal, you can pick any 3 of these 8 sides. Let's pretend that you must pick 3 different things. The question is, how many ways can you order 3 different sides out of 8? In other words, let's say that you go there every day, and every day you order 3 different sides. How many days could you go without repeating the same 3 sides? So, if the order mattered that you ordered them in, then the answer would be 8 times 7 times 6, because there are 8 ways you could pick the first one, 7 ways you could pick the second one, and 6 ways you could pick the third one. But the cashier doesn't care the order that you order them. If you say, I want rice, beans, and corn, you're going to get the same thing whether you say rice, beans, and corn or corn, beans, and rice. How many different ways can you order 3 different sides? Well, let's say that you do like rice, beans, and corn. You could order them in that order. You could order rice, corn, beans. You could order beans, corn, rice. You could order beans, rice, corn. You could order corn, rice, beans, or corns, beans, rice. So 6 possible ways. How did I know it was 6 without just writing them down? Well, there's a very simple formula. If there are n items, the number of ways you can order them is 1 times 2 times 3 times all the way up to n. In this case, the question was, how many ways can you order 3 things? Well, that's 3 factorial, which is 1 times 2 times 3, which equals 6. So, of the 336 ways you can order the 3 items out of 8, with regard to order, you divide by 6 because there's 6 ways to order each combination, and that leaves you with 56. What is the general formula, you might ask, if there are, let's say that the number of sides equals S and the number of picks you're allowed is P. The general formula for the number of ways you can pick P things out of S is S factorial divided by S minus P factorial times P factorial. And let me show that this works with the example question. In this case, S equals 8, so 8 factorial is 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8. And in the denominator, we have S minus P, where 8 minus 3, which is 5, or 5 factorial, so 1 times 2 times 3 times 4 times 5, as well as P factorial, or 3 factorial, which is 1 times 2 times 3. So you can see 1 times 2 times 3 times 4 times 5, which equals 120, in both the numerator and denominator. So let's cancel that out, leaving us with 6 times 7 times 8 divided by 1 times 2 times 3. Well, 2 times 3 equals 6, and there's a 6 appearing in both the numerator and denominator. So let's divide that out. So we're left with just 7 times 8 divided by 1, which is 56. For purposes of this video, let me introduce a function. We'll call the function c of x and y as the number of ways to choose y items out of x, or x choose y, as we would say mathematically, and we'll define that as x factorial divided by x minus y factorial times y factorial. So in the case of the El Pollo Loco example, if the question was how many ways can you choose 3 sides out of 8, we would express it like that, which would be equal to this, which equals 56. So I think that we're finally ready to start talking about poker. So what are the number of ways you can pick 5 cards out of 52? Well, that would be 52 choose 5, which is 52 factorial divided by 47 factorial, 47 because 52 minus 5 times 5 factorial. And that equals 2,598,960. Let's start with a royal flush. Well, that's pretty easy. There's 4 suits for the royal flush: hearts, spades, clubs, and diamonds, and the ranks must be 10, jack, queen, king, ace. So yeah, there's just 4 ways: a royal in hearts, diamonds, clubs, or spades. How about a straight flush? Well, again, we still have the 4 suits, but the span of the straight flush can start as low as an ace, meaning the ace 2, 3, 4, 5, otherwise known as the wheel straight flush, all the way up to 9, 10, jack, queen, king. If it were 10, jack, queen, king, ace, then it would be a royal flush. So if the lowest card can be anywhere from an ace to a 9, in this case the ace counts as like a 1. So there's 9 possible spans for the straight flush. So 4 suits times 9 spans is equal to 36. With the 4 of a kind, there are 13 possible ranks for the 4 of a kind, for example queens, and then there are 48 cards left in the deck for the singleton after you take out the 4 cards for the 4 of a kind. So that equals 624. For the full house, there are 13 possible ranks for the 3 of a kind and 12 ranks left for the pair. For the 3 of a kind, there are 4 choose 3 ways to pick 3 suits out of 4 times 4 choose 2 ways to pick 2 suits out of 4 for the pair. So that equals 13 times 12 times 4 times 6, which equals 3,744. For the flush, well, we've got 4 suits for the flush. And how many ways are there to pick 5 ranks out of the 13 in the given suit? Well, that would be 13 choose 5, but 10 of those ways would result in a straight flush or royal flush. For example, 5, 6, 7, 8, 9 would result in a straight flush. So we have to pick out those 10 sets of ranks that are consecutive. So that leaves us with 13 choose 5 is 1,287 minus, subtract out the 10 and multiply by 4, and we get 5,108. How about a straight? Well, as we just saw with the flush, there are 10 possible spans for the straight, starting with ace 2, 3, 4, 5, going all the way up to 10, jack, queen, king, ace. For each rank in that straight, there are 4 possible suits. So 4 times 4 times 4 times 4 times 4 equals 4 to the 5th power, the number of ways to choose a different suit for each of the 5 cards. But if we choose the same suit all 5 times, then we will also be left with a straight flush or royal flush. So we need to subtract those out. So 4 to the 5th power equals 1024 minus 4 equals 10,200 ways to make a straight. How about a 3 of a kind? Well, there are 13 ways you can choose the rank of the 3 of a kind, and then you have to choose 2 ranks out of the 12 remaining for the 2 singletons. Then, once you do that, you have to pick 4 out of 3 suits for the 4 of a kind, the 3 of a kind, and then 1 suit out of 4 for each of the 2 singletons. So we are left with 13 ways to choose the rank of the 3 of a kind. There are 66 ways to choose 2 ranks out of the 12 left for the 2 singletons, times 4 ways to choose the 3 suits out of 4 for the 3 of a kind, and also 4 ways to choose 1 suit for the 2 singletons. So the answer is 54,912. How about a 2 pair? Well, there are 13 choose 2 ways to pick 2 ranks out of 13 for your 2 pair, and then you will have 1 rank left for the singleton. For each of the pairs, there are 4 choose 2 ways to pick 2 suits out of 4 for your pair, and there are 4 suits for your singleton. So 13 choose 2 equals 78 times 6 times 6 times 4 equals I forgot my 11 ranks for the singleton. So 78 times 11 times 6 times 6 times 4 equals 123,552. For the pair, there are 13 ways you can choose the rank of the pair, and then you have to pick 3 ranks out of the 12 left for the 3 singletons. Then for your pair, there are 4 choose 2 ways to pick 2 suits out of 4, and then for each of the 3 singletons, there's 4 possible suits to choose from. So 4 times 4 times 4 is the number of ways you can choose 3 suits for your 3 singletons. So that equals 13 times 12. 12 choose 3 equals 220 times 6 times 4 to the third power is 64. So that equals 1,098,240. And finally, let's calculate the probability of having ace higher left or less, which I'll just call junk. In order to have junk, you must have 13 different ranks. I mean 5 different ranks out of the 13. So there's 13 choose 5 ways to pick 5 ranks out of 10. But as we saw with the flushes, we have to subtract out the 10 spans that form a straight. Then once you've picked your 5 non-consecutive ranks, there are 5 ways to choose. There's 4 possible suits for each of the ranks. So you take 4 to the 5th power. And as we saw with the straights, we have to subtract out 4 for the number of ways to pick the same suit each time, which would result in a flush. So 13 choose 5 equals 1,287 minus 10 for the straights times 4 to the 5th power equals 1,024 minus 4 equals 1,302,540. So next, let's put that all in a spreadsheet. Okay, let me quickly show you how to do all that in Excel. So we already saw there's just 4 ways to get a royal flush, 1 for each suit. 36 straight flushes, 4 suits times 9 possible spans. For your 4 of a kind, there's 13 ranks to choose from for the 4 of a kind and 48 cards left over for the singleton. For the full house, there's 13 ranks for the 3 of a kind, 12 for the pair, 4 choose 3 ways to choose the suits of the 3 of a kind, and 4 choose 2 ways to choose 2 suits out of 4 for the pair. And the way you express that formula in Excel is with this combin formula. Combin big number, comma small number, just like I wrote it out there. And that gives us the 3,744 we got earlier. For the flush, there's 4 suits to choose from. 13 choose 5 ways to pick, 5 ranks out of 13 in that suit, minus 10 spans that would result in a straight flush or royal flush because they're consecutive. So that leaves us with 5,108 flushes. For the straights, there are 10 possible spans, 4 suits for each card in the span, but subtract out 4 for the 4 suits, which would leave you with a straight flush or royal flush, and we get the 10,200. And for the 3 of a kinds, there's 13 ranks for the 3 of a kind, 12 choose 2 ranks for the 2 singletons, 4 choose 3 ways to pick 3 suits out of 4, and 4 times 4 ways to choose the 2 suits for the 2 singletons. So 54,912 3 of a kinds. For the 2 pairs, there are 13 choose 2 ways to choose 2 ranks out of 13 for the 2 pairs, 11 left for the singleton, 4 choose 2 ways to pick 2 suits out of 4 for the 2 pairs, and 4 suits for the singleton. For the pair, we have 13 ranks for the pair. 12 choose 3 ways to pick 3 ranks out of 12 for the 3 singletons. 4 choose 2 ways to pick 2 suits out of 4 for the pair, and 4 to the 3rd power for the ways to pick 3 suits for the 3 singletons. And finally, for the junk, there are 13 choose 5 ways to pick 5 ranks out of 13, minus the 10 consecutive ways that would give you a straight, and 4 ways to choose each of the suits. So 4 to the 5th power minus 4 for the ways that would give you a flush. So as you can see, the sum of all these is 2,598,960, which we also got at the beginning of this video. Okay, let's go to a practical application of all this. One of the hundreds of casino games that I cover on my website, Wizard of Odds, here is called Let It Ride. So let's pull up that page. And this is a poker game based upon a 5-card poker hand. There's no drawing. It's all based on just 5 random cards out of 52. And I won't get into the whole rules of the game, but there is a side bet that pays based on just the poker value of your 5 cards. And you can see that I list 9 of these possible pay tables here, but table 4 here is a pretty common one. And I already transcribed it into this table here. The bet costs $1. If you get a royal flush, you win $20,000. A straight flush wins $20,000. A 4 of a kind wins $400. And these pays, by the way, are on a 4-1 basis, meaning that you don't keep your original bet if you win. Here's all the combinations, which I already worked out, the probabilities. And this return column here is the product of the win times the probability. For example, there is, as we know from before, there is about a 4 in 2.6 million chance of getting a royal flush. If we multiply that probability times 20,000, it results in expected return of 3.08 cents. So that's how much the player, if he bets $1, he can expect to get back in the form of royal flush winnings. He can expect to get back 2.77 cents for his straight flushes, and so on. So if you do all the math, at the bottom line is that for the player's $1 bet, he can expect to get back 74.4667 cents. In other words, for that $1, the player can expect to get back about 74.47%, and the casino will keep 25.53%. The way I would express that is the house advantage is 25.53%. So just let that sink in for a minute. The casino is keeping more than 25% of that bet, which just goes to show what I have been saying for over 20 years, that side bets are all sucker bets. So if you learn just one thing from this video, I hope it's that. And this is run long enough as it is. My apologies for the length, and I hope this was informative and that you learned something, and thank you for watching.